So let's do a quick review of what we learned about angles yesterday. Here we have two intersecting lines that form four angles. And so we want to know how the angles relate to one another. So we don't know anything about their measurement, but we do know about their relationship. So if you look at angles 1 and 2, when you combine them, they create this straight line or a straight angle. So we could say angle 1 and angle 2 are supplementary. Supplementary angles are angles whose sum is 180 degrees. Supplementary. So are there other supplementary angles? Yeah. So we could say angles 3 and 4 are supplementary. But we also have some other ones, because if you were to rotate this, let's just say you did this. Now you can see that angles 2 and 3 are also supplementary, as well as angles 1 and angle 4. Okay, so seeing that rotation kind of makes that easier to follow. Now, there's other relationships that exist here. And let me put that back the way it was. There was a term you used yesterday called vertical angles. Vertical angles are those that are on opposite sides of the vertex. So if the vertex is here, 2 and 4 are vertical angles, as well as angle 1 and angle 3. And what is it about vertical angles? Well, vertical angles are congruent. Congruent is the correct mathematical term to use when angles or anything is the same size and shape. So those angles, those sets of angles, angles 2 and 4, angles 1 and 3 are vertical angles, and therefore they are congruent. So now let's say we have one measurement of the four angles. Well, then you can calculate the other angles. First of all, if this is a 140-degree angle and it is vertical to angle 2, that means the measure of angle 2 would also have to be 140 degrees. Now, we can also find the measure of angle 1 and the measure of angle 3 using what we know about angles. And one of the things you just know is that there are some supplementary angles here, and the supplementary angles sum must be 180 degrees. So these two angles are supplementary to each other. So if 140 is one of the angles, the other angle, angle 1, must be 40 degrees, because 140 plus 40 gives you 180. Now you could also look at it, I'll use a different color for this. You could say that angle 3 is supplementary to the 140-degree angle. That means angle 3 is also 40 degrees. And obviously angles 1 and 3 are vertical angles, so that makes them congruent also. And here's another example. If this angle is 70 degrees, that means its vertical angle is also 70 degrees. And then angle 1 and 3 are going to be the same because they are vertical. But angle 1 is supplementary to the 70-degree angle. So that would make it 110 degrees, which means, 110 degrees would also work for angle 3. Okay, all right. So I hope you have a ruler or a straight edge. If you don't, pause this video and get one, because you're going to need it. Okay, so I want you to draw two lines, and we're going to label them line L and line M using lowercase letters. And they need to be lines that would intersect but haven't intersected yet. Does that make sense? If this line, because it has arrows, it would continue on, and eventually they would intersect. We don't need them to intersect just yet. Okay, so we have two lines. They are intersecting lines, although they haven't intersected. They're not parallel because the distance between them is not the same, right? This distance is different than this distance, which makes them not parallel to one another. They're also not perpendicular because when they do intersect, it would not be at right angles. So now I want you to draw a dotted line that intersects the other two lines in different points. So using your straight edge, draw a dotted line. And this dotted line is kind of important. it indicates that it is a different kind of line. And it is a line that's called a transversal. And a transversal is a line that intersects two other lines. So this is a point of intersection, let's try that again. This is the point of intersection for line L, and this is the point of intersection for line M. Okay? So the question here is, how many angles are formed by this transversal? Well, we know that anytime you have intersecting lines, there are 4 angles created, right? 1, 2, 3, 4 to line M, and then another 4 to line L and line M both have 4 angles created by this transversal. Okay, so now there are relationships that exist. So what I'd like you to do is to number these angles. So angles 1, 2, 3, and 4 are the angles created with line L. Angles 5, 6, 7, 8 are created by line M. So now corresponding angles lie on the same side of the line in the transversal. So what does that mean? So if you look at angle 1, it falls above line L and to the left of the transversal. So what other angle lies above a line and to the left of the transversal? Well, that would be angle 5. Angle 1 and angle 5 are called corresponding angles because of that very thing. So what other angles are corresponding? Well, angle 2, that's not a good color to do that with. Let's do this. Angle 2 lies above the red line and to the right of the transversal. Well, what other angle does that? Above the line to the right of the transversal, that would be angle 6. They are called corresponding angles. What angle corresponds with angle 4? Well, angle 4 falls below line L to the right of the transversal. So does angle 8. It just falls below the other line. And then that means angle 3 corresponds with angle 7. All right, another term that shows a relationship is called alternate interior angles. Alternate interior angles. Well, let's just think about what those words mean. Alternate means opposite of. Interior means inside. So we're looking for angles that fall on opposite sides of the transversal and lie between the two lines. So let's think about that. The angles that fall inside, because we're talking about interior, would be angles 3, 5, 6, and 4, right? Those are the angles that fall between the two lines. So in this case, we care about the alternate angles. So angle 3 and 6 are on opposite sides of the transversal, as well as angles 4 and 5. Those are called alternate interior angles. And if you just let the language speak for you, it makes pretty good sense. So then what would alternate exterior angles mean? Well, again, opposite on the outside. So the angles that are outside would be 1 and 2 and 7 and 8. Okay? 1 and 2 and 7 and 8 are the angles that fall outside of the two lines. So what are the opposite? Well, angle 1 would be on the opposite side of angle 8. So those two are considered alternate exterior. And angle 2 and angle 7 fall opposite of the transversal and outside the two lines. So they are also alternate exterior angles. Okay, so now I want you to draw two lines, but this time they're going to be parallel. So line L and line M are parallel to one another, and they have a transversal. So go ahead and draw that. Pause the video if you need more time. Now, when we have a transversal that deals with parallel lines, this is only true when you have parallel lines, the corresponding angles are going to be congruent. So let's look at this. if this is angle 1, 2, 3, 4, 5, 6, 7, 8. This is saying that corresponding angles are congruent. So remember, corresponding fall on the same side of the line and the same side of the transversal. So what corresponding lines do we have, or angles do we have here? Angle 1 corresponds with angle 5. They are on the same side of the transversal and they are the same side of the line. They are above the line. So if we look at, does it make sense that these are congruent, the same measurement? So let me just see if I can show you this. If I kind of draw, and I'm doing this on the computer, so it's a little less precise. Okay, so I drew angle 1, right? I just traced angle 1. So now I'm going to take what I traced. Hopefully I can do this. I can do this. Okay, and I'm going to move it down to angle 5. Do you see that it is the same size and shape? Yeah, they are congruent. Corresponding congruent angles will always be, corresponding angles will always be congruent. So what other angles correspond? Well, what corresponds with angle 2? Same side of the transversal, same side of the line, right? To the right of the transversal and above the line would be angle 6. And the same thing, if you look at that measurement of angle 2, it would be congruent with the angle measurement for angle 6. True for all corresponding angles. Okay, what about alternate interior? Do you think the same thing holds there? Let's try this again. 1, 2, 3, 4, 5, 6, 7, and 8. Alternate interior angles are also congruent. So let's try this. Angles 3 and angle 6 are alternate interior, right? They're between the two lines on opposite sides of the transversal. So let me try drawing it again. This is angle 3. Not drawn great, but it's the best I can do with what I got here. Okay, so I'm going to take this angle. And first of all, what else? What's the corresponding angle to angle 3? Well, angle 7, same thing, right? Now, I need to flip this around so we can check it against angle 6. Sure enough, it is the same angle. What corresponds with angle 6? Angle 2. So angles 2, 3, 6, and 7 are all congruent. Now, why is that? Well, how do they relate to one another? 3 and 6 are alternate interior. 3 and 7 are corresponding, and 2 and 3 are vertical. There's a lot of different relationships happening here, but what that tells you is 2, 3, 6, and 7 are all congruent. What do you think happens with alternate exterior? Yeah, I'm guessing you probably already understand that they are going to be congruent also. So let's take a look at 2 alternate exterior angles. How about angle 2? Well, alternate means the opposite side of the transversal. That means it has to be to the left of the transversal. And on the outside of the lines means 7 and 2 are the 2 alternate exterior angles. And again, if you look at this angle here, it appears to be the same as this one. All we would have to do is flip it over.